So, good morning everyone. Today we are going to explore an exciting area of mathematics is called as a combinatorics. So, combinatorics it's all about the counting, arranging and selecting the objects in a sets. So, you know the definition of a set. It is a collection of a subjects or a collection of elements in a certain condition. Yes. So see here first what is mean by a combinatorics. So combinatorics is a branch of mathematics that deals with counting, arranging and selecting the objects. So here the question is, we often to try to answer the question like how many ways can we arrange a set of objects. Second example is how many different selections can we make from a group of options. Yes, so the applications of these combinatorics here, these problems might sound simple at first, but they quickly become more complex as we increase the number of items or add conditions to our choices. So today we will focus on two basic and very important counting principles. So these are sum rule and product rule. So before that, you know the applications of combinatorics. So before dividing into these principles, let's take a moment to understand why combinatorics is important. It's play a key role in many fields of mathematics and beyond. So such as a graph theory, it helps to analyze a networks and relationships. In a statistics, it is used to calculate the probability and manage large sets of data. Computer science, so it is a combinatorics is a critical for designing algorithms and solving the optimization problems. Cryptography, so which is used to keep information secure, relies heavily on combinatorial methods. So by understanding how to count efficiently, we can solve problems faster and more accurately. So let us now proceed with the first basic principle, and it is sum rule, or it is called as a addition rule principle. So the sum rule is a combinatorics is also known as addition rule. So it applies when we have several different tasks and only one of these tasks can be performed at a time. So the formal definition or statement of sum rule is, if there are n1 ways to perform task 1 and n2 ways to perform task 2, similarly you can perform third task in n3 ways, fourth task in n4 ways and so on, nk ways to perform a task k. So the total number of ways to perform one of these tasks is written here, n1 plus n2 plus and so on nk. So however, the key condition here is that the task must be mutually exclusive. Only one task can be chosen. Yes. So let us see here some example on this sum rule. So this is the first example. A student can choose either a math course of 5 options or a science course of 3 options. So by the sum rule, the total number of ways to choose a course is in the form of 5 plus 3 is equals to 8 ways. It means that a student can choose either a math course or a science course. There are 5 different math courses and 3 different science courses. So how many total choices does the student have? So the student have 8 number of choices to choose either of option of mathematics courses and science courses. So thus there are 8 different ways for a student to choose a course. Yes. So I think you understand how this example is applied, or by we can solve this example by using sum rule principle or addition rule principle. So let us see here the second example. So it is a menu choice. Example is on menu choice. So consider here a restaurant offers 4 different types of salad and 6 different types of sandwiches. So if you want to order either a salad or a sandwich, how many options do you have? So again, these choices are mutually exclusive, as you can only order one item at a time. So by the sum rule, the total number of options is equals to 4 plus 6 is equals to 10 ways you can choose a salad or sandwiches. Yes, so you can apply here the sum rule to find out the chosen options for a particular this example. So I think are you understand the first principle of counting sum rule by illustrating these two examples? Yes. So now let us see here, the next rule is the product rule. So next we have to move on a product rule, which is also called the multiplication rule. So this rule applies when you are performing two or more independent tasks, meaning you must perform both tasks, but each task has a separate set of choices. So the formal definition or a statement of this product rule is if one task can be done in m1 ways, and after that another independent task can be done in n1 ways, so the total number of ways to perform both tasks is m cross n ways. Yes, so I repeat again the statement of this product rule. So if one task can be done in m1 ways and another independent task can be done in n1 ways, then the total number of ways to perform both these tasks is given by m cross n or m into n ways. Yes, so let us see here now the example on a product rule. So this is the example of outfit of choices. So suppose you are picking an outfit, you have 3 different shirts and 2 different pairs of pants. So how many different outfits can you create? So here picking a shirt and picking a pair of pants are independent tasks. So by the product rule, the total number of outfit is equals to 3 into 2 is equals to 6 ways. So 6 outputs or outfits are here by choosing a 3 shirts and 2 pair of pants. Yes, so I think are you clear the idea of a product rule principle? So let us see here the next one, next example on this one. So this is a password generation. So in this example, more practical example is this one. Suppose you need to create a 3-character password. Yes, where the first 2 characters are letters and the last character is a digit. So by using this combination, you can find the total outcomes or possibilities of a password that create by using 3 characters and first 2 characters are letters and the last characters is digit by using the product rule. So the total number of possible password is given by, there are 26 characters are there. So you have to take the 2 characters at a time. That's why it is a 26 into 26. And then there are the 10 digits 0 to 9. Yes, so you can multiply 26 into 26 into 10. So this is 6760 ways or possible characters to create a password. Yes, now let us see here the another example is there, just it is left as an exercise. So it is a course and topic selection. So let us return to our student example. Suppose that the student not only needs to choose a course but also a project topic for that course. Yes, so student has 3 science courses to choose from and each courses has 4 different project type topics. So how many total combinations of courses and topics can be student select? So here selecting a course and selecting a project topics are independent tasks. So by the product rule, the total number of combinations is 3 into 4 is equals to 12 ways. So the student has 12 different courses or topics of combinations. So let us see here what we learn in this lecture. So we learn about the sum rule for counting mutually exclusive tasks, And the second rule is the product rule, which we use when we have independent tasks that must be both be performed. So these two rules form the basis for many more advanced topics in combinatorics, such as combinations and permutations, which will explore in future lectures. So for now, I encourage you to practice applying these rules to different counting problems to deepen our understanding. So thank you for your attention, and I look forward to our next lecture. Thanks.